For now, we would focus only on mean. So let's begin with mean. This mean can further be classified into three types. You have arithmetic mean, geometric mean and harmonic mean. Again, this arithmetic mean could be classified under three groups. It can be a simple mean, it can be a mean with frequency and a weighted mean. Now we will understand this one by one as we proceed. So this is an overview of the measures of central tendency. Coming on to the first one, that is mean. It is one of the best measures of central tendency where you are trying to explain an ordinary average. So all the scores are divided by the number of the scores that are there. Let's say I have three kids here. One is little short, just 2 feet. The next is 4 feet and the third one is 6 feet. Now all these three kids, if I want to find the average, how can I understand it? The sum of the values of the height of these three kids would be 2 plus 4 plus 6 and that accounts for 12. Now we divide it by the average, by the number of the kids. So how many number of the kids? 3. So divided by 3 and we get 4 and we can say 4 is the average value that's there. Now with the same example, I have the kids 2 feet, 4 feet and 6 feet. I increase the height of this kid and decrease the height of this kid. Now all the three kids are of 4 feet. So when all the three kids are of 4 feet, what would happen? It would become 4 plus 4 plus 4 and that makes it 12 again. Divided by the number of the kids, which is 3, you have the value which is again 4. So my average in both the cases remains 4 and that's very, very important. The idea is the number of the kids multiplied by the weights that are there would give you the total value. Okay, so in the first case you have 2 feet and 6 feet, that the total comes out to be 12 and this total is equal to the multiplication of the average and the number of the kids that are there. So that's how we understand the mean. Now this same mean I can manipulate it with frequency. How can I do it? Let's say I have a level ground. On this level I have a pointer that would indicate the mean value. What I do is I just slide that pointer to adjust to the mean value. On the first I have 2 kids who have 2 feet of height. I have 4 kids with a height of 3 feet and I have 4 kids again who have a height of 5 feet. So 2 kids with height of 2 feet, 4 kids with height of 3 feet and I have 4 kids with a height of 5 feet. Now what I do is I find the total. So this total could be 2 plus 2, there are 2 kids of 2, or I can do 2 into 2. Similarly, there are 4 kids of 3 feet height, so I can do 4 into 3 or I can do 3 plus 3 plus 3 plus 3 4 times. And similarly, so when I add all these values, so it is the multiplication I can do it as 2 kids of 2 feet plus 4 kids of 3 feet plus 4 kids of 5 feet. So that's 4 plus 6, 4 plus 12 plus 20. So that's 16 plus 20, 36 divided by the total number of kids, which are 2 plus 4 plus 4, that is 10. So 36 divided by 10 is 3.6 feet. So this becomes my mean, and when I have the pointer on the rod, I can adjust it towards the side more than 3 feet and less than 5 feet, and it would be somewhere between 3 and 4 as 3.6. And that is my mean with the frequency that I have calculated. So you have the same number, 2 feet height, but there are more than 1 kids. So we consider this as frequency. Clear? Now, how do we express mean? Mean is simply expressed as summation of x divided by total number of scores, or the summation of all the heights in this case divided by total number of kids that are present. The next case, as I said, so two cases done, the general mean, mean with frequency. Now we have weighted mean. How do we understand weighted mean? This is very simple. Let's say you are in an examination hall and you have the marks weightage that are given for the examination. So let's say the teacher says your homework would have a 25 weightage, classwork would have a 50 weightage, and the final test or the exam would have 25 weight. So this is the weight. Now, what are your scores for the homework, classwork and the test? Let's say in the homework you score 70, in the classwork you score 80, and in the test you score 60. So what is your weighted mean? So weighted mean is calculated as the average by multiplying weights with the score and dividing it by the weights. So it's the summation of weights and the scores divided by the summation of the weights. Now here we can say it's 25 into 70 plus 50 into 80 plus 25 into 60 divided by 25 plus 25 50, 50 plus 50 100. So divided by 100, that makes it 7250 divided by 100, that is 72.5 would be my average score that would be generated, and this is the weighted mean. So understand it very carefully, very precisely, what is a difference between a normal mean, a mean with frequency, and a weighted mean. Now after this, the next thing that we talk about is further interesting, and this is the geometric mean. Now let's take two numbers. I have 4 and 9. So the geometric mean is the square root. In this case, since there are two numbers, we take square root. If there were three numbers, we would take cube root. If there are n numbers, we will take nth root. So let's say you have 5 numbers, so you would have fifth root of n1 into n2, so on till n5. Okay, so that's how you calculate. So here you can either take the square root separately, so I can mark it as 2 into 3, that is 6, or I can multiply this within the square root, that is square root of 36, that again comes to be 6. So this is the geometric mean. Now I do a very interesting calculation. With the same two numbers, I do a arithmetic mean, and my arithmetic mean comes out to be 13 divided by 2, which is 6.5. Now you can apply it to n number of cases, but the final result that you would get is the geometric mean is always less than or equal to the arithmetic mean. It cannot be more than the arithmetic mean. That's rule number 1. The second rule is a very special characteristic of a geometric mean, that is understanding the ratios. So here I take the lower number divided by the geometric mean, and I take the bigger number, which is 9, and this is divided by the geometric mean. In both the cases, I get a ratio of 2:3. So when I write the geometric mean as 4, 6 and 9, I take the ratio of 4 by 6 and 6 by 9. The ratio remains the same, and this is one of the very classic characteristics of geometric mean. A very, very important concept. The next is the harmonic mean. So when I say harmonic mean, it's just a reciprocal of the arithmetic mean. So let's say I have numbers 1, 4 and 4. I have to take out what? I have to take out the harmonic mean. So in this case, it would be 3 divided by 1 by 1 plus 1 by 4 plus 1 by 4. So it's half plus 1. So it's 1.5, and then I solve it. Okay, so I get a value here which is. Now when I solve these values, what is very, very important to understand? So the harmonic mean came to 2. Now for the same numbers 1, 4 and 4, I calculate my arithmetic mean. What is my arithmetic mean? My arithmetic mean is the sum of these 3 digits divided by the number of digits, that's 3. So it's 9 divided by 3, and that's 3. So that's my arithmetic mean. Now if I want to find out the geometric mean, how it would be? Geometric mean is equal to cube root of 1 into 4 into 4. So what it would be? It would be, I can expand it as 2 into 2 into 2 into 2 and cube root. So it would be 2 outside and cube root of 2, and that's my geometric mean. So if I put all these together, I can say harmonic mean would be less than or equal to the geometric mean, which would be less than or equal to the arithmetic mean, and that would stand always true. However, when I want to calculate a relationship between the things which are the harmonic mean, geometric mean and arithmetic mean, how can I do that? I can simply say arithmetic mean into harmonic mean is equal to square of geometric mean. But that would stand only and only true when I have just two values with me. So when I had three values, my values as we calculated, the harmonic mean came to 2, the arithmetic mean came to 3 and the geometric mean came to 2 cube root of 2. And when I try to solve this and put this in this equation, it won't suffice. Now let's change my values. My new values are 4 and 4. With just two values, I calculate all of these again. So I calculate my arithmetic mean. My arithmetic mean is 4 plus 4 divided by 2, and that comes to 4. My harmonic mean is 2 divided by 1/4 plus 1/4, and that again comes to 4. And then my geometric mean is square root of 4 into 4, that again comes to 4. So what I do is, when I say arithmetic mean into harmonic mean, that is 4 into 4 would be the square of the geometric mean, and that stands true. But that would only and only be true only when I have two variables with me. Just with two values. As soon as the number of values changes, my answer won't suffice this equation. So that's very, very important to understand, and most of the places you won't find this on accuracy. Another important rule that you need to understand is, when I say harmonic mean, it is the reciprocal, listen carefully, it is the reciprocal of the arithmetic mean of the reciprocals. Okay, so it's the reciprocal of the arithmetic mean of the reciprocals, and that's why we say when in the case of 1, 4 and 4 we calculated the harmonic mean as 2 and the arithmetic mean would be 3, but here it would be 2 divided by 3 by 2 by 3, and that's the reciprocal of the reciprocal of the arithmetic mean of the reciprocal. So this is the arithmetic mean and the reciprocal of that, and that's why we say this stands true. So very, very important concept. So with this we cover this lecture. We'll be covering many more important sessions for you. So stay tuned. Have a wonderful day ahead.